Good morning, everybody, or afternoon, or middle of the day, or late at night. It's Unit 11, and it's our last video notes. So, make sure you can do these. You made these up. Let's make sure you can do them. So, here's some more specific details about what kind of reactions you're going to see. In your book, you get to see some cool things. In Chapter 16, you might find interesting, so I recommend reading that. So, the three types of reactions we're going to talk about are neutralization, anhydrides, and salt hydrolysis. So here's the basic idea of what goes on when these things react. And so these are some of the reactions acids and bases can do, or ways to form acids and bases. So neutralization is the reaction that's going to help us do a technique later. But it's just acids plus bases give you water and salt. So here we have sulfuric acid, and let's remember we're going to be using aqueous solutions, and sodium hydroxide. Remember to cancel your charges. You got to be able to write the formulas for these. They're going to form water. So we can write H2O, that's going to be a liquid, and salt. But the salt is going to be the positive part of the base coming together with the negative part of the acid. So, because the H2O was the OH and the H. So, you're going to have sodium, which has a +2 charge, and sulfate, which has a -2 charge. I said sodium is +2. Sodium's +1, but sulfate's -1. So, oh my gosh, I got to talk right. Sulfate's -2. Sodium's +1, so we need 2 sodiums in there. All right, now it's not balanced, so we have to go ahead and put a 2 there to give us 2 sodiums and then 2 hydroxides. And then we're going to need a 2 there. Okay, so acid plus base gives you salt plus water. So hydrochloric acid +1 -1, and KOH +1 -1, give you salts. So the salt is going to come from the middle of, or the beginning of the base and the end of the acid. And then you're going to get water. Okay. So why don't you try this one? I'll give you the formulas. HNO2, but you could have got that. And calcium hydroxide, which you also could do. All right, so go ahead and try those ones because you have to write a neutralization reaction. Okay, what are we going to use this for? Well, if we have an acid or a base in here, and then an acid or a base in here, and then we put an indicator in here, when we're adding them to each other, when we get to a certain point, they'll neutralize each other and the indicator will change color. And so this technique is called titration. They don't just use it for acids and bases, but it's when you mix two solutions to get to a final result. The indicator tells us when the reaction is neutralized. Okay, so we're going to do this in class. So it's a technique. Titration is a technique that's utilizing a neutralization reaction. So this is called a burette. Burette spelled differently, depends who you look at or who you talk to. So you rinse the burette with the substance, fill it up, open up the stopcock to let stuff in. Well, you have something in here, right? A certain amount that you measure. And then you put an indicator in there, record how much volume you put in there, and then you add, so if this is base and this is acid, if this is acid, then that's base. So before you start putting stuff in from the burette into the flask, you read the measurement. So here's what it looks like. Look, 21 is here, 22 is here. So how do you read this? Well, this is 21. This is 21.1, 21.2, 21.3. So this is at 21.3. Milliliters. Okay. Then when you let some out, it'll go down, and if it went down to here, it'll go right to there. Right? And this would be 21.5670 milliliters. Okay. And so then how do you know how much you let out? Well, you just subtract it. So that'd be 0.40 milliliters was released. Okay. So always read the bottom of the meniscus, read from the top down. So this is 27.1, 27.2, 27.3. So this is 27.7, and then below that, they're saying it's about a little over halfway between those two marks, so that's 27.6 milliliters. Okay. Why does the color change? Well, when an acid equals a base, a certain pH is reached. So we have indicators that change color to different pHs. Remember litmus and phenolphthalein? So equivalence is when the number of H pluses and the number of OH minuses are equal. Equal how? Equal number of moles. Okay. So there's an equivalence when this equals that, and the endpoint is when the color changes. So we can calculate stuff. If moles of H plus equal moles of H minus, then molarity equals moles per liter. So to get moles, we have to multiply molarity times volume. So if we want moles, we do molarity times volume. So you'll recognize this equation because we used it for dilution, but now we're using it for acids and bases. This is the molarity times the volume of the acid has to be equal to the molarity times the volume of the base. But the acid and the base the acid has H pluses in it, the base have OH minuses. And so we have to put in a number, this is just going to be a number of H's in front of acid. What I mean is HCl, H equals 1. H2SO4, we would put in 2. For OH, if we had AlOH3, then the OH factor would be 3. NaOH, then the OH factor would be 1. Okay? And that number gets plugged in. So let's practice. So we have this reaction going on. There's sulfuric acid, H2SO4, and we have sodium hydroxide, NaOH. So the molarity of the acid. So here's the formula. NaVA equals MdVB, so it's base. And then we need the number of hydroxide ions and the number of hydrogen ions. So the Ma is 0.25 molar. The volume of the acid is 0.025 liters. Notice what I did there, 3 decimal places. The number of H pluses is 2. The molarity of the base is what? I don't know. So once that volume of the base, you could use capitals or lowercase, it's a 2, 0.075 liters. And the number of OH minuses in the base, sodium hydroxide, NaOH is just 1. So then you plug it in, 0.25 molar times 2 H pluses, 0.25 molar, 0.025 liters is equal to 1 times, I don't know, X times 0.075 liters. And so then you just divide by the 1 and the 0.075. And then 0.075. So the molarity of the base, that's the X, is going to be equal to 0.167 molar. Okay. All right, what's going on here? Well, we have HCl as our acid. We have MgOH2 as our base. The molarity of the acid is, I don't know, the volume of the acid is 0.025 liters. The H pluses in our acid is 1. The molarity of the base is 3 molar. The volume of the base is 0.035 liters. And the number of OH minuses in the base is 2. So there we go again with the same formula. So 1 for H plus, 1 is what's missing, and 0.025 liters is the volume. Other side we have 2 for OH minus, 3 for molar, and 0.035 for liters. And so then divide by 1, divide by 0.025, and we get the molarity of the acid is 8.4 molar. It's pretty concentrated. Okay. All right, let's see. pH of salts. So you're thinking of salt, you're thinking neutral maybe. Well, salt is going to be neutral if you use a strong acid and a strong base to make it. You're going to get a neutral solution. Right? But what if you mix together a strong acid and a weak base? Well, then you're going to get a solution, a salt from a strong acid and a weak base is going to give you an acidic solution. Excuse me. Would be an acidic solution. A salt from a weak acid or strong base would be a basic solution. Is a basic solution. All right, so weak and weak is unknown because they're not equally weak. So we can only do this when we have something strong, at least one strong thing. So what does that mean? Okay, here's a salt. How do I know? Well, we got an ionic compound. This came from a strong base. How do I know? Because the Na part comes from sodium hydroxide. This came from a weak acid. How do I know? Because it came from HCl. So what would happen if I put this into water? Well, it's called salt hydrolysis. is when you put a salt in water. Salt in water. Okay. So let's see what happens. If we put this salt in water, here's what's going to happen. You'll get some sodium ions and some cyanide ions. The cyanide ions will react with the water to form HCN. Now, how do I know that? It's because HCN is weak, so it'd rather be HCN than CN minus. And then when that happens, it turns into a hydroxide. So when you put this salt into water, you'll get some hydroxide ions, and that's what makes it a base. Okay? So this is a basic salt. Okay? This came from ammonia, which is a weak base. This came from nitric acid, which is a strong acid. So when you put this into water, the NH4 part, which is a plus, doesn't really want to be NH4 because it's a weak base. So when you hydrolyze, it's a salt hydrolysis. When you hydrolyze this salt, you'll get NH3, right? And what is NH3 would rather be NH3 than NH4 plus. And when that happens, you get H3O plus. And so this would be an acid. So this salt, when you put it into water, turns the water acidic. Okay. Anhydrides made without water. Okay, so we're not even looking at acids and bases right now. We're looking at things with oxygen. If you have a metal with oxygen, like Na2O, then it's called a base anhydride, a base without water. Because it's not really a base until you put it with water. You could get the same thing from MgO, or the same thing from K2O, or the same thing from aluminum oxide. So it's just a metal oxide, right? So non-metal oxides are acidic acid anhydrides. So now we're talking about non-metals with oxygen. So non-metal oxygen, non-metal oxygen. So it's not an acid or base, but when you put it into water, it turns into an acid or base. So let's see that happen. Okay, so what is this? This is a non-metal, and this is oxide. So this is a non-metal oxide. So if I take it and put it into water, it's going to turn into H2CO3, which is an acid. Okay, so non-metal oxides are called acid anhydrides. So it's not an acid or a base, but when you put it into water, it turns into acids to an acid. And so that's why carbon dioxide in the atmosphere helps to contribute to acid rain. Barium oxide is a metal oxide. Right? So it's not an acid or a base, it's a base anhydride. So it's not an acid or base, but it's a base without water because when you put it into water, okay, those are going to be solids. When you put it into water, it turns into barium hydroxide. Okay, and this is a base. So acid and base anhydrides are not acids or bases, but when you put them into water, they turn into acids or bases. So in acid rain, you have non-metal oxides in the atmosphere from pollution and cars burning fossil fuel, and they turn into acid, and then that deposits right into water and turns the water more acidic. Okay. Or it eats away limestone. Right. So to review, three main types of reactions. Acid plus base gives you salt and water. That's a chemical equation that we utilize for titration. We use this formula to calculate the results of a titration. Big Ka's are strong acids, big Kb's are strong bases. So if you mix them together and get a salt, the salt could be acidic or basic depending on what you use. Anhydrides are without water, but when you put them into water, they can turn into acids or bases. So there's a lot of chemical reactions going on. We'll keep talking, we'll keep using them, and that's it. Don't forget to look at cool things and do all this stuff and see if you can do your own objectives. Peace out. It's been fun.